Flux.
What is it?
Why must I know it?
Am I born to suffer?
Before we show you and answer all these questions, we should describe what electric flux is in the English language.
Electric flux is the amount of electric field passing through a surface at a given time, as shown.
You'll notice there is an area and an electric field.
To solve for electric flux, we must first know two important things, being E, the electric field, and A, the surface area vector.
Let's start with the simpler of the two, being electric field. An electric field is, according to Oxford Languages, a region around a charged particle or object within which a force would be exerted on other charged particles or objects.
Basically, imagine field lines drawn away from a positively charged source.
You'll notice there are surfaces within the region around the electric field, which is important in understanding this next part.
Surface area vectors.
Next, we must understand what a surface area vector is. We can define a surface area vector as the normal vector to the surface that is equal to the area.
Put simply, this is what electric flux is, and you can use this formula to figure out the electric flux to the surface.
By the way, that symbol is a symbol for electric flux, called phi.
However, if one were to get creative and wacky, we have the requirement of figuring out electric flux to either a non-uniform surface or a non-uniform electric field, such as this one. Both these situations, shown by the models, require calculus. Cue tears.
This is the formula you must use in case of this situation.
We must understand some important concepts of electric flux. One being, this is all the electric field passing through a three-dimensional object originates from outside the surface, such as shown below. Then because since all the field that enters also exits, the total flux is zero.
However, if there is a charge within the surface, this is not true.
After you finish crying, dry your eyes, as there is a savior. Just kidding. The savior is named Carl.
Carl Friedrich Gauss, pioneer to Gauss's law, as shown, will save all of you from actually doing any calculus. However, that's a story for another time.